So we're going to walk through this skills review, the algebra skills welcome back sheet, and then I'll load up the PDF as well. So you guys will have access to all of this kind of stuff. I had made a recording, kind of recorded that little recording, and the funny, it was too tiny. Like I found this weird resizing thing. So here you're looking at the one I made before. So I'm going to redo this, send it and try and post it again. Let me know if something funny happens and we'll kind of go with that. So this is the first problem. It says graph each equation. So I'm going to walk through somewhat fast, but it's kind of a way for you to say, I couldn't grasp it when you went through it quickly. Can I have more time? And that's something you want to make sure you take advantage of. Things you want to point out, all right, we're doing linear equations. There's a y-intercept in this first one, and there's a slope. And those are the two things that we want to know. Graphing-wise, some of you got this down like nobody's business. I might mess up a lot. Slope, you start with the y-intercept first. You always start y-intercept first, and then you do the slope after that from the y-intercept. And the y-intercept of 2 means on the y-axis you hit it 2. And then a slope of negative 1/2, because slope is rise over run, you're going to go down 1 over 2, down 1 over 2, down 1 over 2. And you can also repeat that in the opposite direction, and you get yourself a line. Connect the dots, and that's enough. We're talking sketches, so these aren't perfect graphs. This one's really pretty easy to do, but we want to know if you have the general idea of what the picture looks like. We're working towards, when you look at that, you instantly have a sense of what the graph looks like. So the more we practice it, the better off. We've talked about forms of equations and saying, hey, I love it when it's y equals mx plus b. This isn't it. So one of the things we would do is get y by itself. We would divide by 3. Now traditionally, all of us would say, all right, I'd divide both sides by 3. Y equals 2x minus 6 all over 3. The thing we need to now understand is that you need to have the skill to divide both terms. If there's multiple terms in the numerator, you need to divide each of those by the term there to split it up, in a sense. Some of us like to look at the, it's going to clash, go better color here. But these here, these are the terms. We're going to split that up, divide each of those by 3. So what I mean by that, we're going to get 2/3 x, because if I divide 2x by 3, minus 6/3, I'm sorry, which is 2. Now we have slope-intercept form. There's a slope and a y-intercept. Here's my y-intercept of -2. And then the slope then of 2/3. We can work from there. Again, you start with the y-intercept of -2. And if you guys get fractions or non-whole numbers, it's okay. Just roll with them. Up 2 over 3. You got to start getting used to that. When we're talking sketches, you don't need perfection as far as the points. So hang in there, down 2 over 3. Just a few points. 2's the minimum. Go for more if you can tolerate. And there's your sketch. Again, it's a sketch. The big to-do is when you divide both sides by a number, when you're coming up with the slope-intercept form, make sure you divide each term by that number so you can get this fancy pants, nice form, mx plus b. All right, now down below, if I give you 2 points, this is where it's usually best to do point slope form, not absolutely required, but I want to use it as an opportunity to show you that the forms of a linear equation are there because sometimes they're more useful. The neat thing about this is pick your favorite. I like 6, -1 for no particular reason. That's going to be my x1, y1. So my equation is almost done. I should do y minus -1, so the y1, and my slope, I don't know yet, x minus x1, and that's going to be the 6. So I'm ready to go. Only thing I need, and that's the nice thing about formulas, is that they're just a place for you to say, what do I need and where do I get it from? I need the slope, and I don't know where it is. Like, oh, I have 2 points. I could do, y2 minus y1. I can get the rise over the run. I could plot them on a graph and count the rise and the run and do a ratio of those two. So it's up to you how you go about it. I love graphs. It's usually my favorite thing anyway. So here's the formula, y2 minus y1, x2 minus x1. y2 and x2, and those things they're labeled as there's a first point and a second point, so it's not something to get too all worked up about, but one of these is x1 and y1, one of these is x2 and y2 in no particular order. It's just that when you do subtract them, so in this case I put y2 on the left, -1 minus -4, from my rise, the change in my y, I need to make sure I do the x subtraction in the same order, the right minus the left. So 6 minus -3. Watch your minus and negatives and things like that. -1 minus a -4 is like -1 plus 4. And 6 plus 3 is 9. I hope all this Seems peach keen to you guys. I'm sure it does. But 1/3 is my slope. So I'm going to take that, drop it off up here in my slope portion of the equation. And that's enough. I'm done. I mean, I don't have to go on beyond that. Somebody said, hey, you need to graph that line. I might solve for y because I like that slope-intercept form of the equation. Now, if I sneeze anytime here in the next couple seconds, pardon me. Okay. The next is, hey, I've got an x-intercept of 3 and a y-intercept of 2. Now you can graph that, and let's think of it this way. If I want y minus y1 and m times x minus x1, all I need is 1 point and an intercept, like an x-intercept, and a y-intercept, or actual points. Now, if you want to go graph those on a graph to kind of see where they're, an x-intercept of 3, right here, bingo. And I might do the y-intercept in a different color just for emphasis here. Here we go. My y-intercept of 2 would be up here. It would be 1, 1, 2, plot, plot, plot. That. So when I put that into context, those are coordinate points. And so if I wanted to label them, I would call, the y-intercept 0, 2 graphically, because it's 0 for the x and 2 for the y. And if I wanted to do my x-intercept, that point there, I'd call it 3, 0. Now, what happens is, if you want to do that without graphing it, there's a lot of confusion that happens. X-intercept of 3, you have to remember that's along the x-axis, where the x is 3 and the y is 0. So some people have a hard time remembering that. In a y-intercept, you can do it just looking at it. In a y-intercept of 2, you just have to remember that on a y-intercept, the y value is 2, the x value is 0, so 0, 2. You can do it without graphing it, but graphing, boy, always saves me a lot of time and trouble. Pick your favorite, 3, 0, 0, 2. One of those is going to be your x1 and y1. I'm going to do 3, 0. No reason, just sounded good to me. So y minus 0, that's my y1. My slope, don't know yet. And then x minus x1 is going to be 3. The slope to be determined. And the way I get my slope, if you want to graph them and do rise over run, great. But I'm going to do rise over run. I'm going to subtract my y's. So let's go in with some kind of fancy pink color. I got a y of 0 and I got a y of 2. I'm going to subtract them. 0 minus 2. And then I've got an x of 3 and a y of 0, respectively, in the same order. If I subtract those, I get negative 2/3. I could have graphed my original. When I graphed those, I could have counted that really nicely. I could have said, hey, that's a rise of down 2 over 3. I can see that. And here, I'm getting the same confirmation from the formula. But I needed the slope, and I just got it. So I take that little negative 2/3, plug it in here, and we're all good to go. Do I need to simplify anymore? No. Is it really easy to solve in this one? Sure. If I take and get y by itself, y meant this finished equation, it wouldn't take much effort to say, hey, that's y equals negative 2/3 x minus 3. It also wouldn't take much effort to distribute that negative 2/3 and write it as y equals negative 2/3 x. And then when you take 2/3 times 3, can you see the 3's canceling, the negative 3 and the negative? Can you see those? So it ends up just being positive. A negative times negative is a positive. It ends up just being 2. All right, so there is our nice form. However, both of these that I've circled are perfectly fine. It's just, what type of form, what do you want it to look like for your purposes? That's what simplifying is. That's what rewriting equations is all about. All right. Today in class, at least one of the classes, I did some factoring on here. I'm going to do a little bit. I'm checking my time on my recording. And I think what I'm going to do is pause here. I got the linear equations, and then I'll do the factoring in a second piece here. All right.